Let's imagine for a moment we had the option to redesign human civilization from the ground up. What if, hypothetically speaking, we discovered an exact replica of the planet Earth, and the only difference between this new planet and our current one is that human evolution had not occurred. It was an open palette. No countries, no cities, no pollution, no Republicans, just a pristine, open environment. So, what would we do? Well, first we need a goal, right? And it's safe to say that goal would be to survive. And not to just survive, but to do so in an optimized, healthy, prosperous way. Most people indeed desire to live, and they would prefer to do so without suffering. Therefore, the basis of this civilization needs to be as supportive and hence sustainable for human life as possible, taking into account the material needs of all the world's people while trying to remove anything that could hurt us in the long run. That goal of, say, maximum sustainability understood, the next question regards our method. What kind of approach do we take? Well, let's see. Last I checked, politics was the method of social operation on Earth. So what do the doctrines of the Republicans, liberals, conservatives, or socialists have to say about societal design? Not a damn thing. Okay, then what about religion? Surely the great creator had to have left some blueprint somewhere. No, nothing I can find. Okay then, so what's left? It appears something called science. Science is unique in that its methods demand not only that the ideas proposed be tested and replicated, but everything science comes up with is also inherently falsifiable. In other words, unlike religion and politics, science has no ego, and everything it suggests accepts the possibility of being proven wrong eventually. It holds on to nothing and evolves constantly. Well, that sounds natural enough to me. So then, based on the current state of scientific knowledge in the early 21st century, along with our goal of maximum sustainability for the human population, how do we begin the actual process of construction? Well, the first question to ask, what do we need to survive? The answer, of course, are planetary resources. Whether it is the water we drink, the energy we use, the raw materials we utilize to create tools and shelter, the planet hosts an inventory of resources, many of which are demanded for our survival. So, given that reality, it then becomes critical to figure out what we have and where it is. This means we need to conduct a survey. We simply locate and identify every physical resource on the planet we can, along with the amount available at each location, from the deposits of copper, to the most potent locations for wind farms to produce energy, to the natural freshwater springs, to an assessment of the amount of fish in the ocean, to the most prime arable land for food cultivation, etc. But since we humans are going to be consuming these resources over time, we then realize that not only do we need to locate and identify, we also need to track. We need to make sure we don't run out of any of this stuff. That would be bad. And this means not only tracking our rates of use, but the rates of earthly regeneration as well, such as how long it takes for, say, a tree to grow or a spring to replenish. This is called dynamic equilibrium. In other words, if we use up trees faster than they can be grown back, we have a serious problem, for it is unsustainable. So then, how do we track this inventory, especially when we recognize that all of this stuff is scattered everywhere? We have large mineral mines in what we call Africa, energy concentrations in the Middle East, huge tidal power possibilities on the Atlantic coast of North America, the largest supply of freshwater in Brazil, etc. Well, once again, good old science has a suggestion. It's called systems theory. Systems theory recognizes that the fabric of the natural world, from human biology to the earthly biosphere to the gravitational pull of the solar system itself, is one huge synergistically connected system, fully interlinked. Just as human cells connect to form our organs, and the organs connect to form our bodies, and since our bodies cannot live without the earthly resources of food, air, and water, we are intrinsically connected to the earth, and so on. So, as nature suggests, we take all of this inventory and tracking data and create a system to manage it. a global resource management system, in fact, to account for every relevant resource on the planet. There is simply no logical alternative if our goal as a species is survival in the long run. We have to keep track as a whole. That understood, we can now consider production. How do we use all this stuff? What will our process of production be, and what do we need to consider to make sure it is as optimized as possible to maximize our sustainability? Well, the first thing that jumps right out at us is the fact that we need to constantly try and preserve. The planet's resources are essentially finite, so it is important that we be strategic. Strategic preservation is key. The second thing we recognize is that some resources are really not as good as others in their performance. In fact, some of this stuff, when put into use, has a terrible effect on the environment, which invariably hinders our own health. For example, oil and fossil fuels, no matter how you cut it, release some pretty destructive agents into the environment. Therefore, it is critical we do our best to use such things only when we really have to, if at all. Fortunately for us, we see a ton of solar, wind, tidal, wave, heat differential, and geothermal possibilities for energy production, so we can strategize objectively about what we use and where to avoid what could be called negative retroactions, or anything that results from production or use that damages the environment and hence ourselves. We will call this strategic safety to couple in with our strategic preservation. But production strategies do not stop there. We are going to need an efficiency strategy for the actual mechanics of production itself. And what we find is that there are roughly 3 specific protocols we must adhere to. 1. Every good we produce must be designed to last as long as possible. Naturally, the more things break down, the more resources we are going to need to replace them, and the more waste produced. 2. When things do break down or are no longer usable for whatever reason, it is critical that we harvest or recycle as much as we possibly can. So the production design must take this into account directly at the very earliest stages. 3. Quickly evolving technologies, such as electronics, which are subject to the fastest rates of technological obsolescence, would need to be designed to foreshadow and accommodate physical updates. The last thing we want to do is throw away an entire computer system just because it has only one broken part or is outdated. So we simply design the components to be easily updated, part by part, standardized and universally interchangeable, foreshadowed by the current trend of technological change. And when we realize that the mechanisms of strategic preservation, strategic safety, and strategic efficiency are purely technical considerations, devoid of any human opinion or bias, we simply program these strategies into a computer which can weigh and calculate all the relevant variables, allowing us to always arrive at the absolute best method for sustainable production based on current understandings. And while that might sound complex, all it is a glorified calculator. Not to mention, such multivariate decision-making and monitoring systems are already used across the world today for isolated purposes. It is simply a process of scaling it out. So, now we not only have our resource management system, but also a production management system, both of which are easily computer automated to maximize efficiency, preservation, and safety. The informational reality is that the human mind, or even a group of humans, cannot track what needs to be tracked. It must be done by computers, and it can be. And this brings us to the next level, distribution. What sustainability strategies make sense here? Well, since we know that the shortest distance between 2 points is a straight line, and since energy is required to power transport machines, the less transport distance, the more efficient. Producing goods in one continent and shipping them over to another only makes sense if the goods in question simply cannot be produced in the target area. Otherwise, it is nothing but wasteful. We must localize production so distribution is simple, fast, and requires the least amount of energy. We'll call this the proximity strategy, which simply means we reduce the travel of goods as much as possible whether raw materials or finished consumer products. Of course, it might also be important to know what goods we are transporting and why, and this falls under the category of demand. And demand is simply what people need to be healthy and to have a high quality of life. The spectrum of material human needs range from core life-supporting necessities, such as food, clean water, shelter, to social and recreational goods, which allow for relaxation and personal social enjoyment, both important factors in human and social health overall. So, very simply, we take another survey. People describe their needs. Demand is assessed, and production begins based on that demand. And since the level of demand of different goods will naturally fluctuate and change around different regions, we need to create a demand distribution tracking system, so to avoid overruns and shortages. Of course, this idea is old news. It is used in every major store chain today to make sure they keep up with their inventory. Only this time we are tracking on a global scale. But, wait a minute, we really can't fully understand demand if we don't account for the actual usage of the good itself. Is it logical and sustainable for every single human to, say, have one of everything made, regardless of their usage? No, that would be simply wasteful and inefficient. If a person has a need for a good, but that need is only for, say, 45 minutes a day on average, it would be much more efficient if that good was made available to them and to others when needed. Many forget that it isn't the good that they want, it is the purpose of that good. When we realize that the good itself is only as important as its utility, we see that external restriction, or what we might call today ownership, is extremely wasteful and environmentally illogical in a fundamental economic sense. So, we need to devise a strategy called strategic access. This would be the foundation of our demand distribution tracking system, which makes sure we can meet the demand of the population's needs for access of whatever they need when they need it. And as far as physically obtaining the goods, centralized and regional access centers all make sense for the most part, placed in close proximity to the population, and a person would simply come in, take the item, use it, and when finished, return it when it is no longer needed. Sort of how a library works today. In fact, these centers could not only exist in the community in the way we see local stores today, but specialized access centers would exist in specific areas where often certain goods are utilized, saving more energy with less repeat transport. And once this demand tracking system is in order, it is tied into our production management system, and of course into our resource management system, hence creating a unified, dynamically updating, global economic management machine that simply makes sure we remain sustainable, starting with securing the integrity of our finite resources, moving to make sure we only create the best, most strategic goods possible, while distributing everything in the most intelligent and efficient way. And the unique result of this preservation-based approach, which is intuitively counter to many, is that this logical, ground-up, empirical process of preservation and efficiency, which can only define true human sustainability on this planet, would likely enable something never before seen in human history. Access abundance, not just for a percentage of the global population, but the entire civilization. This economic model, as was just generalized, this responsible systems approach to total Earth resource management and processes, designed again to do nothing less than take care of humanity as a whole in the most efficient and sustainable way, could be termed a resource-based economy. The idea was defined in the 1970s by structural engineer Jacques Fresco. He understood back then that society was on a collision course with nature and itself, unsustainable on every level. And if things didn't change, we would destroy ourselves one way or another.
A resource-based economy is based on pure logic. If you go on a mountain expedition, you calculate how much food you have, how many people there are, and how long the trip will be. You then arrive at a decision about the resources you need for the expedition. If you send a spacecraft to the moon, you will need to analyse the situation to find out what resources are necessary for your expedition. You will take into account the food, the number of people going on this expedition, and the fuel for such a journey. If you, like a species, want to populate another planet, first, you analyse what resources are available and how many people such a planet can sustain. Well, it's the exact same thing with planet Earth, only that here the monetary system does not take into account the planetary resources. Luckily for us, there is already a plan to organise our world. It is called the Venus Project. A nation without a vision of what the future can be is bound to repeat past errors over and over again. This brief video will outline a vision designed to avoid making the same mistakes. A vision of efficiency, sustainability, and intelligent planning. A vision to lead us into a marvellous new world of unlimited human potential. This vision could be a showcase of what the world can be in our cybernated age. Science and technology could be used for human betterment and the restoration and protection of the environment, serving as an example of the intelligent application of a systems approach. While some people advocate the restoration of existing worn-out cities, this effort falls short of the potential modern technology offers. Repairing current cities results in higher costs of operation and maintenance. It is actually less expensive in the long run to build newer cities from the ground up than to restore and maintain old ones. A total city system approach requires overall planning to attain the highest standard of living for all their city's occupants. The circular arrangement efficiently permits the most sophisticated use of available resources and construction techniques with a minimum expenditure of energy. The most advanced amenities that modern science and technology can provide could be made available to everyone. The city could be a help and learning centre where people from all over the world visit and hopefully emulate this design approach in other parts of the world. Design considerations for this new city include its assembly, the reduction of maintenance, efficient transportation, and its simplicity and durability. This would include the flexibility to permit ongoing and later changes. The city would function as an evolving, integrated organism rather than a static structure. This systems approach envisions assembling entire cities by standardized basic structural elements, which are prefabricated in automated plants and assembled on site. Many of these buildings would be comprised of standard units that can be arranged to meet many different requirements. This approach means that this city can be extremely cost efficient because only one sector needs to be designed, which can be duplicated repeatedly for the completion of an entire city. The outer perimeter would be part of the recreation area with golf courses, hiking and biking trails and opportunities for water sports. Inside this area, a waterway surrounds an agricultural belt with indoor and outdoor agriculture. Continuing into the city centre, 8 green sectors provide clean, renewable resources of energy using wind, solar, and heat concentrators. Waste recycling and other services are located beneath the city. The plan utilises the best of clean technology and harmony with the surrounding environment. The residential district features beautiful landscaping with lakes and winding streams. A wide range of creative, innovative apartment buildings and individual, unique homes would provide many options for the occupants. New and innovative methods of vast mass construction for housing and building systems would inject composed materials into a mould and then extrude the form upward. In some cases, multiple city apartments can be produced as continuous extrusions, which are then separated into individual units. Cranes transport the prefabricated dwellings to site locations. They are then lifted and inserted into a support structure. The apartments are lightweight and high strength. All of these dwellings are designed as self-contained residences. The outer surface of these efficient structures serve as photovoltaic generators, converting solar radiation directly into electricity for heating, cooling and other needs. The thermocouple effect would also be used for generating electricity. The wide range of individual homes are prefabricated and relatively maintenance-free, fire-resistant and impervious to weather. With this type of construction, there will be little or no damage from floods, earthquakes or hurricanes. Their thin shell construction can be mass-produced efficiently and economically. New energy-efficient systems can be installed to supply enough power to operate the entire household. Adjacent to the residential district, there are planning, science and research centres. 8 domes surrounding the central dome house art, music, exhibition, entertainment and conference centres. Lovely parks, lakes, streams and waterfalls are located throughout the entire city. The central dome, or theme centre, contains schools, healthcare, distribution centre, communications networking and childcare. It is also the core for most transportation services, which move people by transfers horizontally, vertically and radially anywhere in the city. This minimises the need for automobile transportation, except for emergency vehicles. Transportation between cities would be by monorails. The central dome would eventually house a cybernated complex, which serves as the brain and nervous system of the entire city. It projects a 3D virtual image of Earth using satellite communication systems which display information on weather, agriculture, transportation, and the operation of the whole city. This cybernated system would use environmental sensors to help maintain a balanced load economy, which avoids surplus and shortages. For example, in the agricultural belt, electronic probes monitoring and maintaining the soil conditions, water table, nutrients, and more. This method of electronic feedback can be applied to the entire city complex. With computers now able to process millions of bits of information per second, they are vital for arriving at correct decisions for the management of these innovative cities. Some of these cities may be total enclosure systems, which are self-efficient. These massive structures would contain residences, parks, recreation, entertainment, healthcare, educational facilities, and more. Everything built in these cities would be as near to a self-contained system as conditions allow. In this total enclosure arrangement, the skyscraper assures that more land is available for parks and wilderness preserves, while at the same time eliminating urban sprawl. Wherever possible, geothermal energy can be harnessed. Geothermal power offers the possibility of an abundant source of clean energy. This source alone can provide enough energy for the next 1,000 years. Regional transportation systems would include a network of waterways and canals. These bodies of water could minimise the threat of floods and droughts by diverting floodwaters to storage basins. In addition, these canals could supply water for irrigation, fish farms and recreation. The canals can also be used for desalination using a method of evaporative condensation. A network of tunnels could facilitate transportation of passengers and freight across the Sahara Desert to all the Earth's regions, free of the effects of sandstorms. These tunnels would be located 30 to 40 feet below the desert surface, with ventilators every 1,000 meters. Water could be pumped from below the surface of the Sahara and transported to all the Earth's regions. In some instances, ships could serve as floating automated plants, capable of processing raw materials into finished products while en route to their destinations. Huge ships and submarines with many removable and interchangeable compartments would carry freight across the oceans. Rather than separated containers, an entire freight section can be automatically disengaged at the port. Bridge designs would be greatly simplified, and bridges can be made corrosion resistant. They would be prefabricated and transported to the site by twin-hulled catamarans. On some bridges, trains could be suspended beneath traffic lines. Colonisation of the ocean is one of the last frontiers remaining on Earth. Prodigious oceanic city communities would evolve as artificial islands, floating structures, undersea observatories, and more. These large marine structures are designed to explore the relatively untapped riches of the oceans and provide improved mariculture, freshwater production, energy, and mining. This could offset land-based shortages. They could also provide almost unlimited riches in pharmaceuticals, chemicals, fertilizers, minerals, oil, and natural gas. Ocean cities would be resistant to earthquakes and greatly relieve land-based population pressures. The population would vary from several hundred to many thousand. Underwater oceanic viewing and research facilities provide expansive panoramic observations of the undersea world in its natural habitat without disturbing the ocean environment. Unsinkable floating sea domes would attract those who prefer unique offshore or island living. In the event of inclement weather, they could easily be towed ashore, mounted and anchored to elevated support structures. Mariculture and sea farming systems are used to cultivate and raise fish and other forms of marine life to help meet nutritional needs. These marine enclosures are designed as non-contaminating integral parts of the ocean environment. A true World's Fair of the future would emphasise the contributions made by all nations toward advancing humanity. Although this fair would provide entertainment, its main function is the deeper understanding of the world we live in and the people who inhabit it. The architectural structures themselves would be jewels of future possibilities, with a wide variety of exhibition buildings. Many of the displays will depict not what the future will be, but what it can be if we use science and technology with human and environmental concerns. It could be a vivid future showcase of human potential. Videos, three-dimensional displays, and full-size diagrams will depict the fabulous advantages for all nations when working together to preserve the greatest gift we have, the resources and beauty of our planet.
Today, more than half of all people in the world live in an urban area. By mid-century, this will increase to 70%. But as recently as 100 years ago, only 2 out of 10 people lived in a city, and before that, it was even less. How have we reached such a high degree of urbanization, and what does it mean for our future? In the earliest days of human history, humans were hunter-gatherers, often moving from place to place in search of food. But about 10,000 years ago, our ancestors began to learn the secrets of selective breeding and early agricultural techniques. For the first time, people could raise food rather than search for it, and this led to the development of semi-permanent villages for the first time in history. Why only semi-permanent, you might ask? Well, at first the villages still had to relocate every few years as the soil became depleted. It was only with the advent of techniques like irrigation and soil tilling about 5,000 years ago that people could rely on a steady and long-term supply of food, making permanent settlements possible. And with the food surpluses that these techniques produced, it was no longer necessary for everyone to farm. This allowed the development of other specialized trades and, by extension, cities. With cities now producing surplus food as well as tools, crafts, and other goods, there was now the possibility of commerce and interaction over longer distances. And as trade flourished, so did technologies that facilitated it, like carts, ships, roads, and ports. Of course, these things required even more labor to build and maintain, so more people were drawn from the countryside to the cities as more jobs and opportunities became available. If you think modern cities are overcrowded, you may be surprised to learn that some cities in 2000 BC had population densities nearly twice as high as that of Shanghai or Calcutta. One reason for this was that transportation was not widely available, so everything had to be within walking distance, including the few sources of clean water that existed then. And the land area of the city was further restricted by the need for walls to defend against attacks. The Roman Empire was able to develop infrastructure to overcome these limitations. But other than that, modern cities as we know them didn't really get their start until the Industrial Revolution, when new technology deployed on a mass scale allowed cities to expand and integrate further, establishing police, fire, and sanitation departments, as well as road networks and later electricity distribution. So what is the future of cities? Global population is currently more than 7 billion and is predicted to top out around 10 billion. Most of this growth will occur in the urban areas of the world's poorest countries. So how will cities need to change to accommodate this growth? First, the world will need to seek ways to provide adequate food, sanitation, and education for all people. Second, growth will need to happen in a way that does not damage the land that provides us with the goods and services that support the human population. Food production might move to vertical farms and skyscrapers, rooftop gardens, or vacant lots in city centers, while power will increasingly come from multiple sources of renewable energy. Instead of single-family homes, more residences will be built vertically. We may see buildings that contain everything that people need for their daily life, as well as smaller, self-sufficient cities focused on local and sustainable production. The future of cities is diverse, malleable, and creative, no longer built around a single industry, but reflecting an increasingly connected and global world.
In Season 1 of The Story of Stuff, we looked at a system that creates way too much stuff and way too little of what we really want. Now we're going to start looking at the stories behind this story of stuff. That's where we'll find ways to turn this situation around. Welcome to Season 2. Ever since I learned where our stuff really comes from and how this system is trashing people and the planet, I've been trying to figure out how we can change it. I've read a lot of these. 100 ways to save the planet without leaving your house. 50 simple things you can do to save the Earth. The Little Green Book of Shopping. I thought these might have the answers, but their tips all start here, with buying better stuff. And they all end here, with recycling all that stuff when I'm done with it. But when it comes to making change, this story of going green, even though we see it everywhere, has some serious shortcomings. It's says that if I become a smarter shopper and tell all my friends to do the same, I've done my part. And if I don't buy all this green stuff, then it's my fault the planet's being destroyed. Wait a minute, my fault? I didn't choose to put toxic products on the shelves or allow slave labor in factories around the world. I didn't choose to fill stores with electronics that can't be repaired and have to be thrown away. I didn't choose a world in which some people can afford to live green, leaving the rest of us to be irresponsible planet wreckers. Of course, when we do shop, we should buy the least toxic and most fair products we can. But it's not bad shoppers here who are the source of the problem. It's bad policies and bad business practices here. And that's why the solutions we really need are not for sale at the supermarket. If we actually want to change the world, we can't talk only about consumers voting with our dollars. Real change happens when citizens come together to demand rules that work. Look, it is important to try to live green. As Gandhi said, be the change. Living our values in small ways shows ourselves and others that we care. So it is a great place to start. But it is a terrible place to stop. After all, would we even know who Gandhi was if he just sewed his own clothes and then sat back waiting for the British to leave India? So how do we make big change? To answer that question, I went back and looked at Gandhi, the anti-apartheid movement in South Africa, the US civil rights movement, and the environmental victories here in the 1970s. They didn't just nag people to perfect their day-to-day choices, they changed the rules of the game. It turns out there are 3 things you find whenever people get together and actually change the world. First, they share a big idea for how things could be better. Not just a little better for a few people, a whole lot better for everyone. And they don't just tinker around the edges. They go right to the heart of the problem, even when it means changing systems that don't want to be changed. And that can be scary. Hey, millions of us already share a big idea for how things can be better. Instead of this dinosaur economy that focuses only on corporate profits, we want a new economy that puts safe products, happy people, and a healthy planet first. Duh! Isn't that what an economy should be for? Trying to live eco-perfectly in today's system is like trying to swim upstream when the current is pushing us all the other way. But by changing what our economy prioritizes, we can change that current so that the right thing becomes the easiest thing to do. Second, the millions of ordinary people who made these extraordinary changes didn't try to do it alone. They didn't just say, I will be more responsible. They said, we will work together until the problem is solved. Today, it's easier than ever to work together. Can you imagine how hard it was to get a message across India in 1930? We can do it now in less than a second. Finally, these movements succeeded in creating change because they took their big idea and their commitment to work together, and then they took action. Did you know that when Martin Luther King Jr. organized his March on Washington, less than a quarter of Americans supported him? But that was enough to make change because those supporters took action. They did stuff. Today, 74% of Americans support tougher laws on toxic chemicals. 83% want clean energy laws. 85% think corporations should have less influence in government. We've got the big idea and the commitment. We just haven't turned it all into massive action yet. And this is our only missing piece. So let's do it. Making real change takes all kinds of citizens, not just protesters. When you realize what you're good at and what you like to do, plugging in doesn't seem so hard. Whatever you have to offer, a better future needs it. So ask yourself, what kind of change maker am I? We need investigators, communicators, builders, resistors, nurturers, and networkers. At storyofstuff.org, you can explore these types of change makers and find your first or your next step to take action. Being a responsible citizen starts with voting. That's one of those basic things that everyone's just got to do. But it gets way more exciting and fun when we put our unique skills and interests to work alongside thousands of others. I know that changing a whole economic system is a huge challenge. It's not easy to see a clear path from where we are today to where we need to go. And there's no 10 simple things we can do without leaving our couches. But the path didn't start out clear to all these guys either. Dr. King said, faith is taking the first step even though you don't see the whole staircase. So they worked hard to get organized, practiced the small acts that built their citizen muscles, and kept their focus on their big idea. And when the time was right, They were ready. It's time for us to get ready too. Ready to make change and write the next chapter in the story of stuff.